Okay, this is the second half of the midterm review. So you're going to be watching the first video if you want before 65. Which atom in the ground state is stable electron configuration? So stable, this is code for noble gas, which is that. At STP, graphite and diamond are two solid forms of carbon. Which statement explains why these forms of carbon differ in hardness? It would be the arrangement of atoms, where graphite is in sheets and diamond is interconnected. So graphite and diamond have different molecular structures is our answer. Graphite is a metal, but diamond is non-metal? No, they're all carbon. Good conductors and poor conductors? No, they're all non-metals. Which statement explains why is neon in group 18 an element? Neon is a gas, so what? Other gases are not in group 18. Neon has a low melting point, irrelevant. Neon atoms have a stable valence electron. Yes, that's true. Neon atoms have 2 electrons in the first shell. That's true, but many elements do, so that's not unique to group 18. Which group 14 element is a metalloid? So that would be sharing a zigzag side. So tin is not sharing a zigzag side. Silicon is, so that's our answer. Lead is way low, and carbon is too high up. Which element has both metallic and non-metallic properties? So this means metalloid. Rubidium is all the way to the metals. Radon is noble gas. Silicon is, again, along the zigzag. And strontium, no, that's a metal. Which is a liquid at STP. You have to know these. There's only 2. There's bromine, which is a nonmetal liquid, and there's mercury, which is a metal liquid. So bromine. Which element is malleable? Good conductor of electricity at STP. So we're looking for metals, which would be D. This is a solid, but it's a non-metal solid. And this is also a non-metal solid, so that would mean poor conductors. This is gas. Aqueous solutions of compounds containing element X are blue. Element X could be, transition metal, copper, transition metals. This middle section here. What is the number of electrons in Al plus 3 ion? So Al plus 3 means we've lost 3 electrons. So aluminum normally has 13, but we've lost 3. So it's 10. In general, atoms of transition elements in period 5 are characterized by an incomplete, which one? So you can go to honors reference table, periodic table, and let's look at period 5. So we're talking about yttrium on over. So the 3p is full, so that's not it, because we're all the way down in the 5 by then. The 4p is full. 3D, let's see, 5s, then we're going to go to the 4D. No, 4D. Yes, that's our answer, because after 5s, then we have 4D, so that's our choice. What is the net charge? That means overall charge of an ion that has 8 protons, 9 neutrons, don't care about that, neutral, 10 electrons. So 8 positive, 10 negative. So that's 2 more negatives minus 2 charge. When lithium loses an electron, what happens to the ion and what happens to the radius? So when you lose electrons, you become positive. And when you lose weight, you get smaller. So when you lose electrons, your radius is smaller. As the elements in period 3 are considered in order of increasing atomic number, what is a general decrease in? Okay, so 78, period 3, I'm just looking at periodic table. Atomic mass goes from 22.9, 24, 26, 28, so atomic mass increases. Atomic radius, I would have to take a look at table S this time. So starting with number 11, 11, atomic radius. 160, 140, 124, 114, 109. That's the answer. If I looked at electronegativity, which I don't really need to, it's 0.9, 1.3, 1.6. Okay, that's increasing. Ionization energy, 496, 738, 578, 787. That's going up too. Which characteristics generally decrease when elements are considered left to right, period 3 again. So non-metallic properties decrease. No, you're going from metal to non-metal, so that's not going to do it. Metallic properties decrease, yes. And we just realized from 78 that atomic radius is also going to decrease, so it's 79. This again is table S. So you should be looking at that. When an atom of phosphorus becomes a phosphide ion, what happens to the radius? So if you're -3, that means you're gaining electrons, which means you're gaining weight. You get larger radius, so gaining electrons, you're going to increase. Which substance cannot be broken down by chemical change, which means elements. So the only element here is gold. Butanol, compound, propene, compound, water, compound. Which general trends in first ionization energy and electronegativity values are demonstrated by group 15 elements considered from top to bottom? So group 15 starts with nitrogen, moving on down. So we're looking for ionization energy. So nitrogen is 1402. And then phosphorus is 1012. And then arsenic is 944. So that's going to decrease. So not this one. And electronegativity, 3. And then phosphorus is 2.2. And then arsenic is 2.2. I guess I'll keep going. Antimony is 2.1, so that's also going to decrease. So they're both going to decrease. That's an A. Which change is most likely to occur when a molecule of H2 and a molecule of I2 collide with proper orientation and sufficient energy? So when molecules are colliding like that, we're going to have a chemical change. And if you have a chemical changes, we're forming compounds. You're not going to be forming elements. In the formula XSO4, what is X? So we should probably figure out that the polyatomic ion sulfate is a -2. So X has to be +2 because there's no crisscross and all that junk. So this is a +3. Argon's noble gas, +2, +1. So magnesium. What is the chemical formula for lead, Roman numeral 4 oxide? So lead, Roman numeral 4 means lead +4. Oxygen's -2. Be careful not to crisscross. I'm going to need 2 of those, so PbO2A. Or you could crisscross and then simplify. Which is strontium phosphate? So strontium is Sr +2. Phosphate is PO4 -3. So SR3, PO4 taken twice in parentheses. Iron, Roman numeral 3 oxide. So iron +3, O -2, crisscross, Fe2O3. Choice B. The total number of atoms in the formula is, okay, so Na2, so that's 2, plus 1 from carbon, plus 3 from oxygen, plus 20 from hydrogen, and 10 from oxygen. Because I distributed the 10. So 2 plus 1 plus 3 plus 20 plus 10 is 36. In which compound is the ratio of metals to nonmetals 1 to 2? So I got to write these. So calcium +2 for all of these. Bromine is a -1, so that's going to be CaBr2. So metals is 1, nonmetals is 2. It's probably going to be that answer. This is going to be CaO, this is going to be Ca3P2, and this is going to be Cas. The name of this, so it's a decahydrate, 10, and then it's sodium carbonate, so B. You're not going to use dyes or bis because that's not how we do it. The name of a chemical compound ends in IDE. The compound is binary. Binary. No. The name of the corresponding formula is Na2SO3. So that's sodium. And then SO3, I'm going to look on table E. SO3 is sulfite. Sodium sulfite. Which is correctly named? Lead. Okay, so this is lead in a carbonate. Does lead carbonate's -2, so lead would be +2. No. Copper 1 bisulfate. This is just regular sulfate. Iron 3 chlorite. So iron plus 3 works. Is that chlorite? Chlorite is ClO2. Yep, that's it. I'm going to stop there. What is this? Potassium. Okay, that's my favorite, permanganate. What is the GFM of this? Okay, so periodic table. I've got Fe is 56 and 3 times nitrogen. Distribute. So 3 times nitrogen is 14, so that's going to be a 42. And oxygen is 16, but there are 9 of them. Because I had to distribute. So adding those up, I get 242 grams per mole. Which equation is balanced? So making sure we have the same on both sides. So 2 potassiums, 1 potassium. Nope. 1 sodium, 1 sodium. 2 hydrogens, 3 hydrogens. Nope. 1 calcium, 1 calcium. 4 hydrogens, 4 hydrogens. 2 oxygens, 2 oxygens. Choice C. 97. When it's balanced, what's HCl? I need some room. Guess I'll have to go here. There's no room. Gosh darn it. I have to go up here. So Al is 1, O is 3, H is 4, Cl is 1. Al is 1. I'm just counting up the atoms. O is 1, H is 2, and Cl is 3. Okay, so I need this to be a 3 to balance out chlorines. Let's see how this works. Oh, darn it. That's too much. That's 6 hydrogens now and 3 chlorines now, and we still have the 3 oxygens. And the 1 oxygen has, this is going to be a 3 here. I'm going to get rid of this. It's supposed to be nothing. So now I have 6 hydrogens and I have 3 oxygens. Yes. Darn it. No. Oh, wait, this is here. Yes, that's it. So 1, 3, 1, 3. So hydrogen chloride is going to be a 3. Hey, it even takes me a while to do this. In balancing a chemical equation, one makes use of which law? Conservation of mass. The total mass on both sides has to be equal. Which is balanced? 4 hydrogens, 2 hydrogens. Nope. 1, nope. Oxygens are bad. C looks good. Yeah. The formula mass of the compound, that's GFM, is the sum of the atomic masses of its atoms. Number 100 is A. What is the GFM of this? Okay, GFM. It's 3 times calcium, so that's 40 times 3. I'm looking up on periodic table. Phosphorus, there's going to be 2, so 2 times 31. And then there are 8 oxygens times 16 is 128. So let's add those up. Hold on. Just adding them. And you get 310. Okay. Oh boy. What is the total number of moles of oxygen in 1 mole of that? So that's kind of a silly question, but it's 2 moles of nitrogen, 3 moles of oxygen, the molar ratio. So we're going to go with choice C. Substance has an empirical formula of CH2, molar mass 56 grams per mole. So what's the molecular formula? So I need the empirical, This is 12. This is 2 times 1 is 2. So 14 is our empirical GFM, and molecular is 56 GFM. So that's a factor, multiple of 4. So multiply these subscripts by 4, C4H8. The empirical formula is CH3. What is a possible molecular formula? So we want a 1 to 3 ratio. This is a 1 to 4 ratio. This is a 1 to 2 ratio. This is a 1 to 3 ratio. So it's a C there. This is a 1 to 2 ratio. What is the empirical formula? Okay, so percentages to grams. I don't have a lot of room. I apologize. Where the heck can I do this? I don't have room. All right, so just trust me here. So 28 divided by the GFM of iron is 56. So we're going to have 0.5 moles Fe. 24 divided by sulfur, which is 32. So 0.75 sulfur. This is moles of sulfur. 48 divided by 16 is 3. So now that we have moles, divide each by the smallest. So 0.5, 0.5, 0.5. So Fe should be a 1. 0.75 divided by 0.5 is going to be 1.5. 3 divided by 0.5 is a 6. So we're going to have to double all those. So Fe is going to be a 2. Sulfur is going to be a 3. And this is going to be a 12. It's going to look a little bit different because we've got some polyatomics going on, but these two, C and D, have Fe2. So which one would have 3 sulfurs? Both of them would have 3 sulfurs, but only part D would have the 12 oxygens. And the only reason why I doubled it is because of the 0.5. If it was 0.9, round it up. If it was 0.1, you keep it low. But the 0.5 means you double everything. If you need more help with that, reach out to me, or there are other videos. Percent composition. So part over whole times 100. Chlorine. So it's nice. It gave us the full GFM. So all we need to do is find the part. So 35 divided by whatever it gives us times 100. Because they're all 1 chlorine. So 35 divided by 52 times 100. First one is 67%. Nope. 35 divided by 68 times 100. That's 51%. Nope. 35 divided by 84 times 100. That's 41.6. That's 42%. I'm guessing that's my answer, but just for kicks. 35 divided, that's 100%. That's 35%. So it is choice C. Another empirical formula. Okay, so percentages to grams. 46.7 divided by the GFM of nitrogen, which is 14. Oh, hold on a second. So it's 3.33 moles of nitrogen. 53.3 divided by the GFM of oxygen. So it's going to be, oh, look, it's going to be a 1-to-1 ratio. Because it's the same moles, divide each by the smallest, you get 1-to-1. So 107 is an A. Let me erase. Percent composition of nitrogen. The tricky part with this one is there are 2 of them. So it tells you your whole, but your part is 14 times 2, which is 28. So 28 divided by 96 times 100 is 29.16666, which is 29.2. Smallest percent composition by mass of chlorine. So they're all 35. I remember that from before. Our part is 35. Hydrogen is a 1, so that's going to be 35 over 36 times 100. That's going to be huge. Potassium is 39 plus 35, 74. And lithium is 7 plus 35. 42, and sodium is 23 plus 35, 58. So I don't even need to do the division. I just see there's the biggest gap in this first one. And they'd all be 100 times 100. So I'm going to go with B. Getting there, folks. Which type of chemical reaction does this represent? So it looks like we've got Ki, and on the other side we got Kf. And we have something bumped out. This is a single replacement. If you wanted to be more specific, this is anionic single replacement because we've got nonmetals replacing. 3 types of chemical reactions: decomp, single replacement, solidification. No. Decomp, single replacement, double replacement. Yes. I'm not even going to look that. What is this? It looks like we've got 2 simple things coming together. It's called a synthesis or a combination reaction. During all chemical reactions, everything is conserved. Conserved. The coefficients in a balanced chemical equation represents the not mass ratios, but the mole ratios. We were talking about that earlier. Total number of electrons. What? No. What kind of reaction? This looks like we've got 2 do-si-dos. This is a double replacement. What is the missing product? Oh, I hate these. Oh, okay, hold on. It's a combustion, so it's not that hard. So we have a hydrocarbon and oxygen, CO2 and H2O. I thought I was going to have to do all this work, but I didn't have to. Yes. All right. Stoichiometry. So let's see. Number of moles of H2O, 2 moles. So 2 moles. I seek H2O, so that's this. I know this. So 6 over 4. 2 times 6 over 4. So 2 times 6 divided by 4 is 3. Choice C. Mole ratio of NaOH to AlOH3 is a 6:2, which can be simplified down to a 3:1. Grams. All right. This is a lot of work. Okay, you can do it. So 0.5 moles of this. I seek oxygen, and I have this. So mole ratio first, 5 over 2. So 0.5 times 5 divided by 2 is 1.25 moles. And then I need grams of O2, so that's 16 times 60 is 32, 40. There we go. Whew. Lowest electronegativity value, definitely not going to be fluorine. Francium, 87, is 0.7. Chlorine, 17, 3.2. Chromium, 24 is 1.7. B. What is the total mass of water formed when 8 grams of hydrogen reacts? Okay, so grams to grams. Okay, so 64 divided by GFM of oxygen, 16, is 4 moles times, I seek water, I know, oh shoot, I'm given both. Is this what I'm using? Yeah, I guess I'm using this. So a 2 over 1, so 8 moles of water. 8 times 18 is 140. I screwed it up. Coming back to that. Coming back to all that. 124. I'll come back to those. I'll just tell you. You know what? I'm just going to tell the answer. 121 is D. 122 is. You need your expanded mole map. I really want to get this done in my planning period. 123 is A. Ask me in class. 6.02 times 10 to the 23rd atoms is 1 mole. So which of these is correctly lined up with its GFM? No. Yes, it's A. No and no. At STP, 1 liter of helium contains the same number of atoms as 1 liter of this. This is Avogadro's hypothesis, which says that any gases at the same conditions of temperature, pressure, and volume would have the same number of molecules. Which symbol represents an atom in the ground state with the most stable? You want a noble gas. Greatest tendency to attract electrons at the electronegativity. So number 6, carbon is 2.6. Silicon, number 14, is 1.9. Chlorine, number 17, is 3.2. Sulfur number 16 is 2.6 D. Strong leaf is that. Greatest attraction for electrons. No, nonmetals. Nonmetals. And yellow solid, you just got to know that. Earth science, got to know that. All right, look. I kind of gave up on some of those stoichiometries. If you have questions, just ask me in person. I'm feeling lazy, and I want to get this done before lunch. So with that, any questions, reach out. Thank you.